Conditional probability. The probability that an event B occurs, given that an event A has already occurred, is called the conditional probability. It's called conditional probability because one event is relying upon the other event having occurred. So it's the conditional probability of B given A, and we write it like this. The probability of B, that vertical bar means given A. Note that A and B are independent events if and only if the probability of B is equal to the probability of B given A, since the probability of event B does not depend on the occurrence of event A. The table shows the results of a class survey of 28 students. They were asked, did you do a household chore last night? First thing we're asked to find is the probability that a student did a chore. The probability of a student doing a chore. 14 students said yes, they did a chore out of the total 28 students who were polled. So half of the students did a chore last night, half did not. Number 2, find the probability of a student doing a chore given that the student was a male student. Well, if we focus in on male only, then 7 out of the total 15 males. So given that they were male, the probability that they did a chore was 7 out of that 15. Number 3, find the probability of a student not doing a chore given that the student was female. Well, if you look at the table and total up your females, there's 13 total females. How many of them did not do a chore? 6. So the probability that they did not do a chore, given that they are female, is 6 out of 13. Sometimes you can just think through conditional probability, like we did in the last couple of examples, or use data given to you to write it down. But we also have a formula that you can use if you need it. So the conditional probability formula says the probability of B given A is equal to the probability of A and B divided by the probability of A. So you put it over the likelihood that the first event occurs, and in the top then you calculate the likelihood that both events will occur. So we can redo problem 3 using that formula. So event A is that the student is female. Event B is that they do not do a chore. So the probability of event A is 13 out of 28. There's 13 females out of 28 total students. The probability of B not doing a chore, so if you look at the chart, 14 total students did not do a chore out of the total 28 that were polled. So the probability of A and B, so the likelihood that they didn't do a chore and they're female, that's that lower right hand corner of your box, that's 6 out of 28. 6 females did not do a chore out of the total 28 students that were polled. So the first one and this last one are all we need. We don't really need the probability of B. These events are not independent, so one does affect the other. And so we're going to use our formula here. We're going to take the probability of A and B, 6 over 28, and put that over the probability that event A occurs, that the student is female, which is 13 out of 28. But we never divide by fractions, instead we multiply by the reciprocal. So I'm going to multiply by 28 thirteenths rather than dividing by 13 28ths. Remember, you can cross-reduce anything in the top, you can divide out with anything in the bottom, and equal 1, so that we're left with 6/13, which is exactly what we got when we kind of just thought our way through it. But the formula is there to help you whenever you need it.